Hey, welcome to the Explainer. If you've ever looked at a poll or a study and wondered, how'd they decide how many people to ask? Well, you are in exactly the right place. Today, we're going to break down that tricky statistical concept with a method that's, believe it or not, surprisingly delicious. So let's head into the kitchen and see how a master cook solves one of the biggest challenges in statistics.
That's the fundamental question, isn't it? It doesn't matter if you're testing a new app, polling for an election, or running a huge scientific experiment. At some point, you always hit this wall. How many people do I actually need to get a result I can trust? To answer that question, we're not going to some fancy lab or a boring lecture hall. Nope, we're going to a kitchen. And our guide is a master biryani cook who, it turns out, faces this exact same problem, just with a much, much tastier subject. So, picture this. You're in a massive hall. The air is thick with the amazing smell of spices. The cook has made a giant pot of their famous biryani. But before it goes out to hundreds of guests, they have to be absolutely sure it's perfect. And this, right here, is the cook's dilemma. You see, it's a question that goes way beyond just taste. It's about confidence. How many different opinions does the cook need to hear to be sure that the entire massive pot of biryani is flawless? So let's dig into the cook's recipe for finding that magic number. Now, here's the thing. The cook doesn't just guess. They have this system, a set of 7 rules, 7 key things they think about that helps them figure out the perfect number of tasters. And what's so cool is that every single one of these rules maps directly onto a core statistical idea. Let's unpack this recipe. Okay, first up is something the cook calls spoilage strength. Now, in the world of stats, we call this the effect size. And it's basically just about how big or obvious the problem is that you're looking for. Are we talking about a complete disaster or just a tiny little imperfection? And here's where it gets a little counterintuitive. Think about it. If the chicken in the biryani is totally burnt, that's a huge, obvious problem, a large effect. You only need 1 or 2 tasters to go, yep, this is burnt. But what if the spoilage is subtle, like the salt is just a tiny bit off? To be sure about that, you're going to need a lot more tasters to agree. So here's the key takeaway. The smaller and more subtle the effect you're looking for, the bigger the sample size you need. All right, next, the cook thinks about the spice spread. In statistics, this is what we call variance. This isn't about the average taste of the whole pot. It's about how consistent the biryani is from one plate to the next. Are all the servings basically the same? So consistency is everything here. If every single plate is perfectly identical, that's low variance. Then a few tasters will give you a really accurate picture of the whole pot. But what if one plate is super salty, another is kind of bland, and a third one is too oily? That's high variance. To understand the true average quality, you have to invite way more tasters to capture that whole range of experiences. Okay, our third rule is all about the strictness of the judge. The formal term for this is the significance level, or alpha. This is all about how sure you need to be that a problem you found is real and not just some random fluke. It's like your standard of proof. Let's put it this way. A really strict judge, one who wants to be 99% sure before they declare a problem, is going to demand a mountain of evidence, and that means you need more tasters to convince them. On the other hand, a more lenient judge, who's cool with being 95% sure, needs less proof, and so you need fewer tasters. It's simple. The higher you set your standard, the bigger the sample you're going to need. Rule number 4 is what our cook calls guessed strength, and in stats, we call this power. Now, this is kind of the flip side of the last rule. This is about making sure your team of tasters is strong enough to actually find a problem if a problem really exists. You really, really don't want to miss a real flaw and serve bad food. So just ask yourself, how bad would it be to serve slightly spoiled biryani? If it would be a total catastrophe that you absolutely cannot let happen, then you need high power, like a 90% chance of catching that flaw. And to build a tasting team that reliable, you need more tasters. If you're okay with taking a bit of a risk, well, then you can get by with fewer. So next, the cook has to think about how they're choosing the tasters. See, they know that if you put a bunch of people at the same table, they might start influencing each other's opinions. It's a kind of groupthink. In statistics, this is a known issue called a design effect, which can come from cluster sampling. The solution isn't just to add more tasters to the same few tables. It's to get opinions from more different tables to make sure the feedback you're getting is truly independent. Okay, now we're getting into the really practical, real-world stuff. The cook calls this one empty plates. because no matter how fantastic the biryani is, the cook knows that some tasters are going to get full or get a phone call or just wander off before they give their final verdict. This is the classic problem of dropouts and non-response. So what do you do about it? Well, the solution is actually pretty simple and pragmatic. If the cook knows they need 100 solid opinions, but they expect about 20% of tasters to drop out, well, they can't just invite 100 people. They have to oversample. They've got to invite extra tasters right from the beginning to make sure they end up with the number they actually need. And finally, we have the rule that, let's be honest, often trumps all the others, the budget factor. Look, the fancy statistical formula might tell the cook they need 500 tasters for absolute, rock-solid confidence. But if they only have enough rice and chicken to serve 200 people, then 200 is the limit. End of story. Reality always gets the final say. Whew. Okay, so that was a lot, right? 7 different rules. How in the world are you supposed to remember all of that? Well, our cook has one last trick for us, a simple and really memorable phrase that ties this whole thing together. Here it is. Just remember, spicy effect, mixed plates, strict judge, strong guests, similar tables, empty plates, and a small budget. As you can see, each little part of that phrase is a perfect, easy-to-remember stand-in for a complex statistical term. Spicy effect, that's your effect size. Mixed plates, that's variance. It's just a brilliant little tool for holding all these ideas in your head at once. So, let's tie it all together. What have we really learned from our trip to the biryani hall? We've learned that figuring out a sample size isn't just about plugging some numbers into a cold formula. It's actually a delicate balancing act. It's a balance between the two sides of the recipe. On one side, you have all the pure scientific factors, the effect size you're looking for, the variance in your population, and the levels of significance and power that you demand. But on the other side, you've got the unavoidable practical factors, the reality that some people will drop out, and the hard limits of your time, money, and resources. And that brings us right back to our key takeaway, that powerful mnemonic. It really contains all the wisdom of this process. It's a reminder that choosing a sample size is both a science and an art, and it's always governed by this dance between ideal standards and real-world constraints.
And that leaves me with one final thought for you. The next time you see a poll in the news or you read the findings of some new study, you can use this exact framework. Ask yourself, how spicy was the effect they were looking for? How strict was their judge? And, as this final slide asks, and maybe this is the most important question of all, what was the cook's budget? Thinking about that might just change how you see the results.